Yes, 10 a.m. Can you hear me? You give me my test go. Can you not hear me? So you can see me and hear me at the same time? Because I'm logged into the Google Meet. Cool. Because I have my camera on my computer, but my mic on my iPad. So hopefully it's easier to hear. But yeah, everyone right now is at lunch, so we're waiting for them to come in. And then everyone that's at home, hopefully is gonna join soon. Our period is a little bit later, though we're not starting until 11:18 with the new schedule. But I had lunch last period, so I was able to open it a little earlier. But yeah, eventually you're gonna see them all come in, and I can hear them down the hallway. They will be coming. Right. Hello, Nancy. Hi. You can sit in anything with a pen. What do you think? All right? Yeah. Lunch was probably a little weird, huh? I think it is fast. Speed racer. Boy, sit in anything with the letter A. You can sit in the same seat if you remember from last week. You don't have to. But anything with an A. Look at that. I'm not gonna need you to. They're kind of more, if I push your tables together, you're sitting really close. Definitely want them at lunch. We can have your mask down. But I'm not gonna make it unless you feel more comfortable. Your office needs to walk you down. You don't need it. No. Where's my mask on? Perfect. And so have our friends joining us in the meet. Well, I had it open. I opened it at 11:10, which is really early. But I figured. You alright? Yeah. I figured I didn't have anybody in here, so I might as well get them all hooked up and set up. But hello, gentlemen. Hey. Anything with the letter A. More than welcome to sit where you sat last week.
We have to put the shields up and down.
Wait, can I get to the bathroom?
Yeah, I have to.
Hold on, just one at a time. Okay. Hello, welcome back. Anything with the letter A, just really just every other seat. Give you some space. You're also waiting for Mrs. Taylor. Is Taylor here today? No, she's not. You're a lone wolf over here, Gracie. You guys are depending on each other to keep each other sane. So then this is everybody, right? Really, all the boys. And then when Marty comes back, Liam, you can go, and Liam comes back, and you can go. Just safety, and there's limits on the bathrooms, how many people can go in there. So rather sit here than down there. Okay, so we are starting lesson 6, which there is a link in Google Classroom to get on Nearpod. Those of you at home, You can join the link just like regular. Go in there and follow. It's gonna open up and say using equations to solve problems. If you're in the room, I'm gonna give you the option to log in Nearpod, or I have like a paper printout. Who would rather have the paper printout? That's what I was thinking, because I made second period all use the iPads, and putting it nicely is to say it was a disaster. So we will just go old school, just notes. Typically, if we're using the book, you would want to bring your workbooks every day, and you would have the option to do the work in the workbook or on your iPad. But I'm getting the feel that you guys don't like doing it on the iPads, right? You're just kind of sick of it. So we're gonna go old school here, which is all good. But if you're at home, you don't really have the option. You can go into Nearpod. I am going to end up sharing my screen in the Google Meet. So you could choose to kind of just stay in the Google Meet and watch my screen as I go, but then you just won't be able to work on this. That's nice. Okay. But just to clarify, can everybody at home hear me? Type it in the chat because I can't, my computer's just too far away from me. So I have my mic on my iPad and my camera on my computer. Okay, so what we're doing today is talking about kind of solving problems without the tables that we have been doing. So I'm gonna flip the screen. So then we have our first problem. Cool. Okay, so it says Nicole is making lemonade to sell for a school fundraiser. Allie is also making lemonade, but she is selling it at different booths. They want to see who can sell the most. So they're just gonna have like a little competition. Nicole's recipe calls for 2 tablespoons of lemonade and 3 cups of water. Allie's calls for 1.5 tablespoons of lemonade and 2 cups of water. So that first question is what I want you to work on. At home, you can be in the Nearpod app. Those of you in here, just work on question number 1. Do we think they're gonna taste the same? This is the first thing we started doing in Unit 2, comparing juice. Yeah. Anybody else in pencil? Okay, so you're given the ingredients, and you're given the number of tablespoons of mix and the cups of water. So whose is going to taste the same? Once you answer that, try to figure out whose you would rather take. I'll take you one first. See, Jordan, eventually I'm going to be able to do this for you. This is every day, I forget this. So I have Nicole saying 2 tablespoons to 3 cups of water. Allie saying 1.5 tablespoons to 2 cups of water. Will they taste the same? Whose would you rather buy? And I can see everybody at home already working there. So then just to clarify for those of you that are at home, when I start going over this, I'm gonna write the answers out. So I'm gonna end up sharing my screen. You might wanna toggle back and forth between the Google Meet app and the Nearpod, but that might kind of be a headache. So if you just wanna stay in the Google Meet, that's up to you. But if we're trying to figure this out, we need to compare kind of what we have. So I have Nicole showing 2 tablespoons of lemonade mix and 3 cups of water. So if I need to figure out if they taste the same, I'm gonna freak out. I might actually freak out. Because that just crashed. This is not a good sign. Okay. What has today shown all of us to have a lot of while we're working?
Patience.
Patience, Alex. Yes, lots and lots of patience. You just spoiled me. Yep. Okay, so those of you at home, my computer crashed, but it is fine. Keep answering that question. You guys can just keep working on that one while I try to hook it back in. So as we're doing this, we're trying to figure out the mix per cups of water. So you want to divide it that way. Take the tablespoons of mix for each student and the cups of water. And I may just have to do it like this. Lots and lots of patience. Has this been happening for all your classes pretty much today? Things just like crashing, and then you guys probably just being like, this is really annoying. I believe it, because that's kind of where we are. We're just on hold. No, my question. Okay. We're getting there. Here we go. Okay. So we're back on. So as I was saying, if we're trying to figure out whose drink is stronger, we need to go ahead and divide it out. So we need to figure out how much mix per cup of water. So if Nicole has 2 tablespoons of water, or 2 tablespoons of mix to 3 cups of water, and we go ahead and divide that out, our ratio of mix to water for each girl. For Nicole, we would take 2 divided by 3. What does 2 divided by 3 give you as a decimal?
1.5.
Oh, that's 3 over 2. That's 3 over 2. So careful. Anybody know what 2/3 is as a decimal? Marty?
I got it, and I got it, but then I lost it.
Okay.
Yeah, I lost it.
Okay. Gracie?
0.2.
It's okay. So 2/3, if we divide that out, gives us 0.6 repeating. You could divide it out like you did, Alex. I just went a different way, so you could do 3 divided by 2. So this was Nicole, mix per water. So then I want to go ahead and do the same thing for Allie and take 1.5 teaspoons of mix to 2 cups of water. So in your calculators, you would do 1.5 divided by 2, and you get 0.75. So then are the recipes going to taste the same? No. Why not? Marty?
There are two different like, I don't know, like ratios?
Yep, exactly. So this is my ratio, 2 different ratios. It's the constant of proportionality. 2 different numbers means they're not going to taste the same. So whose would you rather buy? Or whose would you rather drink? This is Nicole, and this is Allie. And we took mix per water. So whose would you rather have? Whose do you think is going to be stronger and taste better? Marty? Allie and Nicole.
Allie, I think.
Because that decimal is larger, so that means she has more mix per water. So remember that the videos that I showed you to watch on the Google form where I was making lemonade, and one was really dark and some were really light. The darker one had more mix in it per cup of water, so that was the first thing that we did. We would rather drink Allie's lemonade because she has more mix per water, and I divided them out evenly. Okay, I'm gonna switch the slide. I know I didn't share my screen with you guys to go over that because I had some technical difficulties, but we'll move on here. So now we're given some tables, and we're going to fill those tables out. So it says Sarah is also selling lemonade. Her recipe calls for 3 tablespoons of mix and 4 cups of water. Complete each table below and find the constant of proportionality in each. We already found the constant of proportionality for Allie and Nicole. That's what we just did. But take a minute to fill out your tables. Nicole, Allie, Sarah. I know that first piece of information. I know Nicole has 3 cups of water to 2 tablespoons of mix. Allie has 2 cups of water to 1.5 tablespoons. And then Sarah is my new information. I have 4 cups of water to 3 tablespoons of mix. So fill in the rest. Figure out how many tablespoons you need for 1 cup for each girl. And then that bottom row, you're just going in and doubling. So if I double each recipe, how much mix are we gonna need? And then once we go over this, then we'll go ahead and share the screen. So to fill in our tables, you need to find your constant of proportionality. So that means take one number from the right and divide it by the number on the left. So if we're looking at Nicole's table, we're gonna do 2 divided by 3, which we just did on the other page. 2 divided by 3 was 0.6. That's your constant of proportionality. So that's what you're gonna use to take everything on the left to multiply over to here. So what's 1 times 0.6? 0.6. And then if I have 6 cups of water, I could multiply that by 0.6, but there's also an easier way to look at Nicole's table. What else can we notice? If I doubled here from 3 to 6, what can I do to my 2 to get down here? Okay.
Multiply by 2.
Yep, so then how many tablespoons of mix do I need for 6 cups of water?
1.
So you're gonna fill in those other 2 tables the same way. You can find your constant of proportionality by dividing right to left and multiplying that through, or you can find your scale factor moving up and down. Let's see how we're doing over here. Perfect. So be careful. I see some of you guys at home. Whenever you have a repeating decimal, so we're getting 0.6 for that first one, try to use 0.6 repeating. So when you're using your calculator, type in as many 6s as you can, because it's going to change your answer a little bit. But I am going to share this out. Let's share my screen here. Okay, so you can watch us in the Google Meet on the screen. So for Allie's table, what's my constant of proportionality going to be? When I do that first step here, 1.5 divided by 2, that's what we just did on that other page. Do you guys have your calculators? Do you have a calculator app on your iPads? You can use that. So you can use calculators. If you have that. Even if you don't have a calculator app, if you just open up Google, yeah. Is that what you did, Jackson?
Yeah.
Just open it up in
There
Google?
is a room.
That's fine. So we're gonna do 1.5 divided by 2 to find our constant of proportionality. Those of you that are at home today, gonna thank you for being patient, but it's gonna be very slow moving today to while we get going. Nathan, that's okay. Just if you can just type it into Google and it will do your work for you. So what do we get when we do 1.5 divided by 2?
Can I use my phone too?
Yeah.
Wi-Fi.
Yeah, if you wanna use your phone for your calculator, that's fine. What's 1.5 divided by 2? Gracie? 0.75, so that's my constant of proportionality. That's how many tablespoons per cup we have. So 1 times 0.75 is 0.75. 4 times 0.75 is how many tablespoons of mix for 4 cups of water. Jackson?
3.
Yep. And again, we can get that the same way, noticing 2 times 2 is 4, 1.5 times 2 is 3. So then we're gonna go ahead and do Sarah's table. So find her constant of proportionality. 3 tablespoons of mix divided by 4 cups of water, which is 3/4 as a decimal. Alex?
3.
Wait, what'd you say?
3.4.
No, sorry, I thought you were saying 3/4.
0.75.
0.75. Top number divided by bottom number. So again, that's my constant. So 1 times that number, 0.75. And then if she uses 8 cups of water, how many tablespoons of mix is she? Jaden?
Got 6.
Either doing 8 times that constant of proportionality, which was 0.75, or noticing that 4 times 2 is 8, 3 times 2 gives you 6. Moving up and down like that is finding your scale factor. Going left to right is using your constant of proportionality. Okay, so my constants of proportionality for each of those tables, take your right side divided by your left side and use it to multiply all the way through. So first thing that we did in Unit 2. Then we started talking about equations. Okay, so I'm gonna erase all of this messiness here. So last week we started talking about equations. So what we're gonna do on this same slide is go ahead and write an equation for each table. So above each table, put an X over the cups of water and a Y over your tablespoons of mix. X to Y, X to Y. Again, if you're in the Google Meet, you can just watch my screen for this. If you're getting a little bit lost where we are, I'm sharing it out. So when we're writing an equation, it's always, what did I do to get the right side of the table? I took my left side times the constant of proportionality and it gave me this. So we're basically saying, I found my tablespoons by taking 0.6 repeating. Have you seen that little line above your numbers before?
Mhm.
That's how you show a repeating decimal. So we're taking our constant of proportionality times whatever is on the left, so times our cups. But whenever we're talking about writing equations, we just want to shorthand that. We don't want to write all of those words. So if I let the letter X represent my cups of water and the letter Y represent my tablespoons, instead of writing out that word, I can just say Y equals 0.6X. All that's telling us is just all the math that we did. I took my numbers over here, or my X values, multiplied them by my constant of proportionality, and I got my numbers over here. What do you think my equation would be for my second table? Marty?
X times,
Mhm.
0.75.
So 0.75, which is my constant of proportionality, times the cups, which I'm just using the letter X instead of writing out that word, equals my tablespoons, which we're just using the letter Y. So your equation is just a really short way to write that big clunky sentence. How did I get all of my numbers over here? I took my number of cups, multiplied it by 75 or 0.75, and I got my tablespoons. I just don't want to write out all of those words. So we would say I got my tablespoons by taking my constant of proportionality and multiplying it by the cups. Good with that? Somewhat? We're gonna look at a new problem. So I'm gonna flip your screens if you're in Nearpod. We're gonna talk about going to a concert. And I know everybody in this room would totally go to a Taylor Swift concert, right? I know. Couldn't you hear the sarcasm in my voice? Okay, so it says for her most recent tour, Taylor Swift wanted to sell out Heinz Field. To do this, she needed to sell 68,400 tickets. That's how many seats there are. She expected to make $6,156,000 in sales from those tickets. Just try to answer question number 1. Assuming that all tickets have the same price, what would the price be for one ticket? So read through that first sentence again. If there are 68,400 tickets and she's expected to make $6,156,000, what would the price for one ticket be? So what are we getting? How much for one ticket? Gracie, what did you get? How'd you get $90? Because when we started talking about constants of proportionality, it was all about the language. So price per ticket means take your price divided by the number of tickets. So 6,156,000 divided by 68,400 gives you $90 per ticket. And I see some people in the Google chat or whatever this is, the Nearpod, going in and actually writing it out like a table like we just saw. So she went ahead and drew a big T-chart, put the number of tickets on the left, the price on the right, to find that constant of proportionality. It's the same thing here. We're just not using a table. We're just picking out the language that we know. Price per ticket means take the price divided by the number of tickets. So question number 2 says, how much will she make if she only sells out half of the stadium? There's a couple different things you need to do for that one. Full stadium is 68,400 seats. If she sells out half of that at $90 a ticket, what is she gonna make? See, the masks make it so hard to see who's talking. How much will she make if she sells out half? What are we getting? Marty, what do you get?
Oh. Okay, come back to me.
Alex, you wanna
What?
go? Try this one.
3,078,000.
Yep, how'd you get it?
I did, I divided, 6 million by 2.
Yep, so there's two ways to go about this. Take that price for filling out the whole stadium and cut it in half. And that's gonna give you your price. Did anybody do it a little bit different? Jaden?
I divided 68,400 by 2.
Exactly. So first step you could take is take your full stadium, cut it in half to figure out what half of your seats were, and then take that and multiply by the constant of proportionality. So if I take half of 68,400, multiply it by 90, remind me again what our final answer is. How much is it gonna cost? Jaden?
3,078,000.
3,078,000. Okay, two different ways. You can find the shortcut easy route by just taking the full stadium cost and cutting it in half, or you can cut the seats in half and then multiply it by that constant proportionality. Question number 3 now says, what if she sells 10,000 tickets, 50,000 tickets, 1,000,000 tickets, or X tickets? So there's 4 parts to that. So see how many of those you can figure out. If she sells 10,000 tickets, how much money is she gonna make? 50,000 tickets, 1,000,000 tickets, and then we're throwing that X in.
Tickets.
Throwing that X in like we did with the table. So what does that X even mean? Where's that?
Should be a billion.
Billion, yeah. Even more than a billion.
You already?
Yeah. She definitely is. So how can we start figuring this out? If she sells 10,000 tickets at $90 a ticket, how do I figure out how much money she's gonna make? What do you do? No, $90 for one ticket, I sell 10,000 of them, how much money do you make? Right, take your 90 times your 10,000 and you get your costs. What if I sell 50,000? $90 a ticket times 50,000 tickets, what do you do?
4,500,000.
Right, because you're multiplying. 50 tickets times 90,000 or 50,000 gives you your answer. What if it's 1,000,000? $90 a ticket times 1,000,000 tickets gives you $90 million. So now my main question here is, what does this X mean? If it says X tickets, what is that even asking us?
What the constant of proportionality is?
Yep, so we need to know that. And then what does X stand for here? Jaden? How many tickets? So when it asks us for X tickets, it's saying, what if I don't know? So I don't know if it's 10,000, or I don't know if it's 50,000, or if I don't know if it's 1,000,000. How do I write a roll to show any number of tickets? So how did we find all of those answers? What did we do with the constant of proportionality and how many tickets there were? What math did we do? How do you find the cost for any number of tickets?
Multiplication.
Huh?
Multiplication.
Multiplication. So you're taking your constant of proportionality, which is $90, times however many tickets that is. So it's just a shorthand way of going through all of those big
It's
numbers that we
90
just did.
times, 90 times X.
So that's your expression. Question number 4 says write an equation. So all that means is that I can take that first roll that I did, 90 times the number of tickets, what is that gonna give you? That's always gonna give us the cost. But again, equations just mean shorthand everything. So I don't wanna write out the word tickets, I don't wanna write out the word cost, so I just wanna use different letters. So if it's telling me to use the letter Y for cost, I'm just gonna replace it and say, my constant of proportionality, or $90 per ticket, times the number of tickets is equal to how much money I'm gonna make. So when it asks you to write your equation, it's just asking you for that pattern that you did, okay? Then you're gonna take that pattern that you're thinking in your head and you're just shortening it using a bunch of letters. So the next problem. Perfect. So if you are still working at home, I can see, I'm gonna switch the slide though. All of your answers look really good. But we're gonna look at the next one. It says, if they make $2,700,000, how many tickets have they sold? So try and think about that. Think about what you're gonna have to do. They made $2,700,000, so how many tickets were sold? So what are we doing? Where are we getting? I made $2,700,000 at $90 a ticket. How do I figure out how many tickets there were for to begin with? Or how many tickets I sold?
1,000. Wait, what? Wait, that's not.
What do we get? Alex? You know where's in here? What do we get? Crazy? How'd you get it?
90 divided by 2.
So this time they gave me the cost, $2,700,000 divided by $90 per ticket gives me how many tickets there are. So this is just like when we have those tables and you have a number on the right and you have to go backwards. So instead of using your constant of proportionality to multiply, we're dividing it out. 2,700,000 divided by $90 gives you 30,000 tickets. How many will you have to sell to make $5 million? Find that answer. $5 million, selling them at $90 a ticket. How many will you need? Perfect. Yep. I see everyone at home getting the 30,000. So now try and do the question number 2. So if it's $5 million at $90 a ticket, what are you gonna get? $30,000 tickets, $55,000 tickets. So where are we getting? How many tickets, Marty?
5,555,555,
All the fives. So we have 5,555.55 tickets. And then there's a 6 put at the end of your calculator because it's just rounding it. So does it make sense to sell half of a ticket?
No.
No. So if I sell just 55,555 tickets, I'm not gonna have enough, right? I wouldn't make enough money. So I would have to make sure to sell that other extra ticket, so I would round it up, which mathematically you would round up anyway, right? If you have a number bigger than 5, you round it up. But we have about 55,000 tickets. Okay, so again, same idea as what we looked at last week with the tables. If we're going left to right, you're using your constant of proportionality to multiply, or if we're going backwards, you're dividing. It's that same type of idea. Good with that. Okay, for 10th period, which we still have 10 minutes left in here, so I'm gonna explain and then get everyone that's in here set up and ready to go for that. There is a set of practice problems. So if you're at home, there is an independent Nearpod that you're just gonna pace yourself through that you're gonna work on. Check in 10th period if you need help. I have printouts for you guys. Would you rather have a printout of the worksheet than have to use your iPad?
Yeah.
So I'm gonna hand you that now so you can have 10 minutes to get started on that. That way we're gonna finish off early from 10th period, okay? And then there's also an end puzzle video for you to work on. So overall, you guys would always rather have like hard copies of things to do rather than use your iPad in class. Just asking so that I get a feel for what you would rather do.
Thank you.
So if you're at home, we finished, that was the end of our class Nearpod, so you are more than welcome to get started on your independent one, which there's a link right in Google Classroom, task 2, and then there's also an end puzzle, so you can get started on that. But you guys, I can see all your answers that are submitted here. You got 55,000 tickets, so you guys are good to go. Yep, that is all right. And then if you're in here, you're just working on those practice problems. And handful of word problems, if you need help, we can all work on them together. What would you rather do? We'll do them together? How about I'll give you 10 minutes to work on it, and then when we come back 10 period, we can go over it. Okay? So we'll do that. So you might be able to finish it. There you go. Let's see what you can get done on your own. And then when we come back 10th period, we'll work on it and go over it together. So even if you want to pick and choose some problems on here, do what you can, and then we'll all come back together to start. And again, those of you that are at home, you are free to sign out of the Google Meet to get started on that thing, or you can hang out for the next 10 minutes if you need help, or it's 8 minutes now. It's up to you. How are you doing? I know you're doing nothing. Literally nothing. At least just leave your paper out. Right? Well, I would rather get it done early now instead of rushing at the end of 10th period and then taking them and not doing it. Isn't that your MO? Huh? Need help? So distance is equal to 65 times the number of time. So what's your 65 tell you? Like that. You're in 65 miles per hour. Yeah. So then if you go for 1.5 hours, that's 65 miles per hour. This equation is telling you to take 55 times the number of hours and take the distance. So you can, and then. Okay. Can help. Per period. Get this form and other assignments. Okay, so we'll work. Just take a step by step. Zeros right now, just to keep track of what's going on. But whatever you turn in, just to create it. Okay. All right? You good? So that's 65 miles times 100 hours is your distance. So it's 100 hours times time distance. Yep. So you've got 5 minutes. When we come back to end period, we're gonna finish this, we'll go over this, get it done together. Short ed puzzle video that you can watch. And actually, well, this class we're gonna be doing makeup work, because there's a lot of us in here. That I'm looking at people, but that doesn't mean that it's necessarily you. People on mainly that recipe project. Yeah, I saw this. I'm still in the process, yep, I'm still in the process of grading them. I wanted to, I was on a road trip on Friday, I was trying to download them. So start looking at them in the car and what that means.
I messed up the table a little bit, I actually put one extra roll.
That's okay. Yeah, that's perfectly fine. As long as your math's right. It's gonna take me a while to grade through them all, they're long, but I'm excited to look through them. What I've seen, they look really good. You guys know where you're going next period?
Mm-hmm.
Who do you have?
Life science, you said how
Is this the, wait, day one, right?
Your days always go as like the day of the week. Monday 1, Tuesday 2, Wednesday 3, Thursday 4, and Friday.
Oh, is that six?
6 is Saturday. Day 6 means sleeping.
Wait, what day is it today then?
Day 1.
So there's all good.
So if you ever forget what day it is, just like, it's just correlated with the day of the week. And then Wednesdays are kind of your day days. Your off days.
Itchy. Let's close out of here. Now I need this.
So that sounds fun. You have the concept for engineering cars? Oh yeah, she's the first period. Yeah, so you're not her. I think Mark, you get your.
Yeah, I am.
You're right.
It really helps to get like work done if you're missing it.
Yeah, it's just like a little study hall.
I don't think I have any work besides like one other thing I have to do, but that's from today.
Yeah, you shouldn't, I don't think you're missing anything. I mean, you're pretty good at keeping on.
Yeah.
I'm not.
So if you can sign out of the Google Meet if you're at home. This period is gonna be over in a minute. In 1 minute, Olivia. You'll hear the bell. Our lovely, it does. And then I am almost right across from that church, so you'll hear that sometimes maybe go off, like the church bell. Alrighty, enjoy science. I'll see you back later.